All right, let's take a look at number 17. So the very first question says to find the domain. So that means that we're going to have to set the denominator equal to 0. Now, normally I would add the 4 over and square root, but I'm noticing that factoring this difference of squares is going to be helpful for further questions. So x times x is going to get us the x squared, and a -2 times a +2 is going to get us the -4. So when we set each piece equal to 0, it's just going to change the sign because you'll have to do the opposite, right? If it says -2, we add 2. If we set x plus 2 equal to 0, it should get us a -2 because we had to subtract it to get it over to the other side. Okay, now these are the values that x cannot be. You plug these values back in, they're going to make the denominator equal to 0. So can't divide by 0, so we're going to have to remove these numbers. So I'm going to put holes where they are, but everything else is okay. So we would say that our domain is going to be from -infinity to -2, from -2 to 2, and from 2 to infinity. So that's going to answer the first part as for the domain. Now we're going to go ahead and look at the intercepts. But first, we have to remove all holes. So we're going to take x plus 2. And remember, we factored this as x minus 2, x plus 2. So any common factors of the numerator and the denominator need to be, they're a whole, so we need to remove them, okay? So it looks like we have a whole at, if we set x plus 2 equal to 0, we get -2. Basically, it's just always the opposite sign. So there's going to be a whole at -2. And here is what remains. I'm going to put an approximately sign because these aren't exactly equal. One of them has a whole and one of them has the whole removed. But they're, other than that, they're equivalent. Okay, so if we go to find the x-intercepts, we're going to let y be 0. So we're going to let f of x be 0. So here is what we're going to set equal to 0. Now I claim this will never be 0. It doesn't matter what the denominator is. This fraction can never be 0 if the top is a 1. The only way we can get 0 is if 0 is in the top, right? 0 divided by 5 is 0. 0 divided by 3 is 0. So there's no other way to get a 0 unless there's a 0 in the top. So right away, there's no solution to this. But let's say you didn't see that when you multiplied both sides by x minus 2. Well, then you would end up getting 0 times x minus 2. Well, 0 times anything is 0. And then you get 0 equals 1. So this has no solution, right? So what does that imply? Well, that implies that there's no x-intercepts. So we have no x-intercepts on this particular graph. Let me go put that in here. There is no x-intercept. Awesome. Now let's go and find the y-intercepts. So for the y-intercepts, you're going to take this function that we have, and instead of letting the y be 0, you're going to let the x be 0. So 0 take away 2 is just -2. So we end up with -1/2. So when x is 0, y is -1/2. That's going to be our y-intercept for this. Now, it's really important that when you go to find these intercepts, you make sure you do this canceling first, okay? Because if I just let me just give you an example here, right? Okay, let's just say that you have this graph. I could probably go to the actual graph to make this easier, but give me a second here, you guys. I'll eventually get there. Okay. Maybe I won't. So let me go graph it so you can see. I think it'd be easier that way. So I'm going to go to GeoGebra. And what I'm going to do is I'm going to graph the original, which was x minus 2, just kidding, plus 2, divided by x to the second minus 4. Let me just double check that that's it. I have a bad memory. Okay, cool, that's it. All right, now if you look at this, you see that there's a hole right here, right? Okay, we want to make sure we remove that hole, okay? And by the way, I'm going to type the other graph that we got, which was 1 divided by x minus 2, to show you they're the same. Look at that. That's the blue one. Turn it off, you get the green one. The only difference is the blue one didn't show the hole like the green one did. So this is the one with the hole removed, and this one is the one with the hole, okay? So you want to make sure you go in there and you remove all those holes before you start getting your x and your y intercepts, okay? All right, let's see what we need to do here. The next thing is we need to graph it. Okay, so I'm probably going to go to a new screen just so that I have some more space here because we got a lot of work to do if we're going to try to find these asymptotes. We know that's a lot of work. Okay, so let me go ahead and grab this real fast, a clean picture, and we'll work on that. So we already factored this. We said, okay, this is 1 over x minus 2, right? Okay, so for our vertical asymptotes, factor cancel set bottom equal to 0. We already did the factoring. We already did the canceling. So we just have to set the bottom equal to 0. So we get that at x equals 2, we're going to have a vertical asymptote. And boom. There we go. Okay. By the way, we had 0, a half for our y-intercept, right? So we'll use that too. All right, now we're going to go ahead and see if we have an oblique or slant asymptote. So when I look at the highest exponents, I don't have the top being 1 degree higher than the bottom. So that implies that we're not going to have no oblique asymptote, right? Now we have to determine, do we have a horizontal asymptote? So I'm looking at those and we have the big bottom case. Remember, we can have small bottom, big bottom, or equal. Big bottom always implies 0 is going to be the horizontal asymptote. So I'm going to draw a horizontal asymptote. I'll just do it in red because we already have a black line there at 0. Okay. All right. And then, oops, I just realized I did not put this at 0, negative a half. I put it at 0, positive a half. So let me move. It's hard when the ordered pairs are on the other screen. I can't remember them, but I'm pretty sure it was negative a half, huh? Yes. Okay. So we're good there. All right. Another thing that we said, by the way, was at -2, there was a hole. Okay. So from here, let me just kind of tell you what I'm thinking. I'm thinking that the graph is going to look something like this. Let me kind of talk through why. We have asymptotes at 0, and we have an asymptote here at 2. So we're going to approach 2, and we're going to approach 0. Now, the only thing I need to fix is we said at -2, there's a hole, right? So I'm going to put a hole right here, and that's what you saw in the graph a second ago, okay? Now, as for the other side, either it's up here or it's down here, okay? Now, what you can do to determine that is you could take, for example, the point 3 and you could plug it in. If we take 3 and we plug it in right here, so we get 1 over 3 minus 2, 1 over 1, which is 1. Well, then we can see that we're up here. So this is most likely going to be how our graph's going to look, okay? If I would have gotten a number less than 0, like a negative number, then I would have drawn it down here in this quadrant, okay? All right, I think we're able to go pick these guys out. So let's see, we have a vertical asymptote at x equals 2. We already computed that. We don't have an oblique, but we do have a horizontal at y equals 0 because of the big bottom. And then there is no oblique. You have a horizontal, you can't have an oblique. One or the other. All right, now let's check out which one. Okay. What is the difference? It's got to be this one. It has x equals, let me draw it bigger or make it bigger. It has at x equals 2 an asymptote. It has at -2 the hole. It's below the x-axis here and above the x-axis here. This one is hitting all of the things that we said. So we're going to pick that one. Awesome. Wow, this is a really good question. This includes everything that we've learned. from this section. Again, that makes the question a little bit tougher because there's so many parts to it, but it's great for summing up what we've learned. Hopefully this helps you out with number 17, you guys. Thanks for joining me.